graph would you want to show me? This is the graph. What does it say? As the input approaches what? -1/2. So I want to make sure that I am showing the input somewhere around -1/2. Okay, so let's put a point on the graph. We know how to do that. What do I want this input value to be? Okay, because if I put in -1/2, what's going to happen? I'll just say it's invalid. Okay, so yeah. Now I'm actually wanting to be coming up to it from the greater than -1/2 side, so I would agree. The better one would be -4.99999 and so forth. Do I get a point showing at that? Is it a correct representation of the point that I need? Nope. Closed point means that it's included. So what would I like to have there? Open point. Do you remember how to do the open point? We have to get into attributes. So go to menu, actions, attributes, and if you point to that, it opens up a menu where if you scroll you can do that. Do you need to do this? No, you don't need to do this, but some of you are up on this, so this is good. And it shows me. Now, it has a vertical asymptote. Emma's completely right on that. It has a vertical asymptote. But Emma, is that what we're looking at when we do this problem? No. So be real careful about these. These could be kind of tricky questions, and you won't know if it's coming from section 2.5 or 2.3 or whatever. So you do need to be very careful about that. Okay, any questions on that problem? Yes? If you go to menu and go to actions and go down to attributes, you can change the attributes of anything. So be sure you have it pointing or going to the point on, and then just as a click or enter on your handhelds, and it opens up an attribute box that you can then alter. Okay, good. Let's go on then to our next problem here. The limit as x approaches 1/2 of x squared tangent pi x. Now, you need to understand that the function, what the function is, so be real clear on that. If you don't understand what the function is, then you're not going to evaluate it correctly. If there were a plus in here, let me go back and erase these. What if, this is a what if, this is not what the problem says, but what if there was a plus in here? Would it still be the same function for the limit? No. So on your work, this is why I'm doing this, on your work, if you have, and you want this to be the function and it has a plus in there, if you don't put parentheses around everything, do I interpret it as the entire function? No. You have to be sure that you are very clear. And so for your work, you may just want to always enclose the function in some kind of a grouping symbol, parentheses or brackets or something. That's one of those things that comes up all the time. I see this, and students are always doing it, and they mean to do this, but what they're really saying is, you've got this problem right here. You find the limit of that, and then you add the tangent of pi x. It's not the same thing. Okay, so let's go back. This is our original problem, and this is our function that we're talking about. Direct substitution. So now we have to think about, can we use direct substitution? Well, let's let this limit be, let's let this be the limit as x approaches 1/2, and let's do f of x times g of x. And I will put that in brackets. And let's assign, let f of x be x squared. And let g of x be what? Yeah, tangent pi x. Okay. Now, if we look at the limit as x goes to 1/2 of f of x, and that would be, of course, the limit as x goes to 1/2 of x squared, polynomial function. No problem with that, right? Direct substitution would be 1/4. If we look at the limit as x goes to 1/2 of g of x, or the limit as x goes to 1/2 of tangent pi x, is there a problem? What do you know about the tangent of pi divided by 2? Undefined. Yes, undefined. Now, back in our notes, we have this theorem. By the way, Amber, rather, was it Amber? Did you ask me the question about do we need to know the names of theorems? That was okay. There are some theorems you do need to know by name, but they have names that you can kind of, like the intermediate value theorem. Some of those that have special names that tell you exactly what the theorem's about, those you need to know. But you don't need to know theorem 2.15. I will never call them by these. And properties of infinite limits, you will need to know this because you will want to use them, but I'm not going to ask you anything specific about these. I will be honest and say things like the theorem of intermediate value, or the intermediate value theorem, yeah, it's a neat little theorem. And there are a couple of others we can go back and look at, but make sure you know that. Okay, so in here, do you see any of these properties of infinite limits that's going to help us? Yes. Which one? The product one? Okay. Now this starts off by saying that, and you can read it this way, one of the limits, one of the functions has a limit that goes to infinity, and which means it's undefined, okay, or does not exist. And the other one has a value. Is that our situation, James? Yeah, it's our situation. So it's not, f of x isn't the one, g of x is, but we have one function that does one thing and one function that does the other. So what does our limit of the product tell us? That if you have one that goes to that doesn't exist and one that does, then the product of the limits do not exist. And again, I say this is our reason, not our answer. Okay, so if we go back now to our problem, this is undefined. Okay, if you remember, the graph on this, does things like that, and so forth. And so we have a vertical asymptote right down. Whoops, missed it there, but the vertical asymptote would go, let's see if I can fudge it in there. There we go, right in there. So what about this limit? So therefore, we'll make our conclusion. Therefore, the limit as x approaches 1/2 of x squared tangent pi x, does it exist? No, does not exist. And remember, for me, we're asking, does the limit exist? Our answer is no, it does not exist. Our reason, then, is because it goes to infinity. Actually, it would go to positive and negative infinity, because on one side it's going to infinity, the other side is going to negative infinity. Okay, so we can pull that apart. We don't really have to do a lot of investigation on that. Pull them apart. You know what the tangent limit is, so we can use our information from trig on that. Okay, let's go on. I'm going to jump to this problem. One of the interesting problems, I think, that we come up to. Patrol cars parked 50 feet. Now, I don't know if this is problem 65 or not. It may be. We have a new textbook. I think it is 65. Patrol cars parked 50 feet from a long warehouse. The revolving light on top of the car turns at a rate of a half a revolution per second. The rate at which the light beam moves along the wall is this. So this is the rate. This is the wall. Everyone's had a situation. You know what the light on top of a car does and so forth. And so it is moving in this direction. It's 50 feet from here. This is your angle theta. And the rate at which it moves along the wall, the rate at which it moves along the wall is given by this. Okay, 50 pi secant squared theta. Another way of writing that, because most of us can visualize cosine better than we can visualize secant, would be to say that it's cosine squared theta feet per second. Now the first two questions of this are pretty ordinary. Find the rate when theta is. Okay, not a whole lot that we need to work with on this. It's not a limit. So we'd have 50 pi divided by cosine squared of pi divided by 6. And probably the thing that we need to work on most is, what is cosine pi divided by 6? You might need to say, well, let me go back. She taught us 2 pi, or pi divided by 6 is to 2 pi. The radians of the angle is to the radians of the circle, as the degrees of the angle is to the degrees of the circle. And we come up with d is equal to 30 degrees. Most of us can visualize then a triangle. That might be a 60-30 right triangle. We went over this last week. And if we reflect it over here, and if I let this side be 1, then this whole side is 2, and that's 2. So I've got a 1, a 2, and this is the square root of 3. So the cosine of 30 is adjacent divided by hypotenuse. So the cosine of pi divided by 6 would be the square root of 3 divided by 2. So I'd have 50 pi divided by the square root of 3 divided by 2 squared. Now, I'm recording this, so if you need to go back and look at that again, I encourage you to do so. This is the type of problem that we talked about when I handed back the last quiz that you need to go over on your own. You know, I have processed this before, okay? I have many times I've processed this whole thing that I do here. I own the knowledge on this. You might have memorized it, but do you understand what it is you memorized is the key. So this helps me to know what I've memorized and anyone else who takes it. If you don't, I suggest that you take this problem and try it for yourself, just like you do all those other homework problems if you can't do them on your own the first time. Okay, so I've got, all I have to do is resolve this, and I'd end up with R is equal to 200 pi divided by 3 feet per second. Now, that is the exact answer. So if I ask you for the exact answer, that's what you're going to give me. We don't go out and measure things in this type of, 200 pi divided by 3. I want that much lumber from the lumber yard. We don't do that. So we do need to know, and things like this then, an approximate. And I'm doing all the work for us because I do want to get on to, let's see if I can read that. Got a change of a contact this weekend. I don't know what's going on. 209.4 feet